Welcome to the Middleware Tech YouTube channel. In this series, you'll learn about Java data types. All code examples used in the videos will be available on GitHub. Let's get started.
Okay, so let's talk about this data type part. Now, in Java, there is a total 8 data types is there. Okay, total. I'm talking about primitive data types. 8. What are those 8 data types are there? Like we have byte, short, byte short. Then we have int, and then we have long. Okay. Then we have float, fine, and then double, fine. Then char, and then boolean. Okay, fine. So total 8 data types is there in Java. Okay, and we should know how we can work using these data types, because these are connected with some small concept that we need to know. First of all, this data types size we should know, because lots of things is there related to this size. So byte size is 1 byte, right? Short size is 2 byte, fine. And if I want to get int size, then it is 4 byte. And for long size, it's an 8 byte. Side we should know. I'll tell you why. For float, we use 4 byte, right? And then we talk about double as 8 byte. Now char, we use 2 byte. And boolean, always we use 1 bit. These are the different size for different data types that we use in Java. So when you're working on this total 8 data type, now you'll find a string also, but a string is not a data type. The string is a class, inbuilt class, that is defined inside a default package called lang package. So these are the 8 data types is there in Java, and we should know how to work with these data types. Fine. What I'll do is that we try to explore some more into these data types. Okay. So let's discuss with these data types into more some operations, how to work, and try to explore into this data types. Fine. Okay. So just see here, please. Case 1. I'm using as a case 1. Case 1 in the sense, just see how to use these data types. You'll get lots of good approach. Like assume byte b equal to 3. Okay, and then byte c equal to 4. So I have 2 data types, byte data types. So in the first variable I have assigned 3, and in the second variable I have assigned 4. Fine. Now what I want to do, I want to do some addition. Fine. So b plus c, I have done some addition. So after addition, I have to take that value inside a variable, right? So I have to use by d equal to b plus c. I have done the addition, and after addition, so D contain addition of B plus C, right? Okay. Now here, if you want to execute and print system dot out dot println, yes please. Anyone, what should be the output? I'm going to print the value of D. So what should be the output? Anyone is running on the other side? It will work. If you execute this code, okay, if you execute this code, it will not work. It will not compile and run. You are doing the addition only. Just see here, it will not compile and run. Just check. If I'm going to control C copy, I'm going to execute. Let me check. Let me execute it. Then you can see it will not compile and run. Just see here. I'm going to write here. Okay, create one class data type demo. Okay, and create a main method. String here, yes, right? Okay. Now here I have done the addition. Just see here. I'm printing this. It will not compile and run. It will give an error. Now we have to understand what is the error and why this error will come. Just see here. So file save as data demo.java. Copy. File save as control V data demo.java. Fine. Okay. So just saved, and let me compile and run this code. It will not compile and run. It will give an error. Just see here, please. .java. See here, it is giving some error. What it is saying? Incompatible types. Possible loss conversion. Fine. So what is the problem? Int to byte, some problem. So let me tell you what is the problem here. Problem is that when you're doing some arithmetic operation between two byte type, it will become int. Okay, so after addition it will be int, but what is this? This is a byte. After addition it will be int. Just see here, but what is this in the left side? It's a byte. So what is the size of int? Int size is 4 byte. Yes. What is the size of byte? Size of byte is 1. So what happened? Big container is coming inside small container. That is the problem. B plus C. So what, right? So B plus C become int. So case 1, let me tell you here. Arithmetic operation between two byte type data type always return int. Arithmetic operations between two byte type data type always return int. Okay, so that's why this is going to return an int, right? So size is 4 byte. Fine. This is what the size is 1 byte. So big container is coming inside a small container. That is the problem, right? So what we have to, what is the solution? Solution is that we have to typecast this one using byte. This one I have to typecast with byte. If you are going to typecast with byte, then it will work fine. This is no error. Just see here, file save, just typecast with byte and compile and run. You will not get any error. Where is that program? Yeah, this one, right? So what I'm going to do, I'm going to typecast with byte. Correct, and you'll not get any error. It will work fine. I'll save it. Just see here, compiled, and then I'm going to run. Enter. So it is running fine, right? So that problem resolved. So what I have done, I have just typecast. I've just done the casting, right? So what will happen? It is an int only, but when you do the cast with byte now, it's become int become byte now. So its size is 1 byte. 1 byte coming inside 1 byte. It will work fine, right? Okay. So here now it will work fine. So this casting is called explicit casting. Explicit casting. Explicitly, we have to cast the addition between 2 byte, right? Right? To compile and run the code, right? So that is called explicit casting. So you have to remember this, right? Okay. Fine. Let's come to the second scenario. Second scenario, case 2. Case 2. Any questions you can tell me? Case 2. Case 2 in the sense means what are the different scenario may come related to operations with data types in Java. That I'm just representing as case 1, case 2. Nothing here. Okay. Fine. Okay. Now here, what we'll do is that take float f equal to 2.0. Right? Float f1 equal to 3.0. Fine. Float f2 equal to f plus f1. Fine. Now if you see this float, I'm doing the addition between 2 float type data type. I'm doing the addition between 2 float type data type. So when you do the addition, whether it will work, after this I'm going to print system.out.println. Fine. So I'm going to print the value of float. Fine, f2, right? It will work or not. So let's execute and check. Let's execute. Control C, copy. Fine. Let's execute. Control V. Let's disable this line like this. Comment. So it should copy and run. Let me check it's running or not. So just see here, please. It is saying no, I have not. I have to compile it first, right? It gets updated. Compile. Now see here, when I'm going to compile this code, it is giving some error. See here, it is saying incompatible types, possible loss conversion from double to float. possible loss conversion from double to float. So what is the problem? Problem is that by default, if you define 2.0, it controls it. By default, if I'm going to define 2.0, it is not a float. By default, this decimal value is a double. That is the point. By default, this decimal value is a double. So if it is a double, then what is its size? Just see here, it's a double, its size is 8 byte. F is 4 byte. So big container is coming inside a small container. That is the problem. Again, I'm saying. On the right side, we have float. A double. By default, decimal value is a double. So just write here. By default, 2.0 is a double value. By default, 2.0 is a double value. Right? That's the problem. This is a big container. This is a big container. Size is 8 byte. And small container size is 4 byte. So big container is coming inside a small container, problem comes, right? So what is the solution? Solution is that we have to use 2.0 small f. We have to use this f symbol. If you are using this f symbol, then compiler will count it as a float. Now it is a float. Now it is not double, it's a float. Both is float, and addition between float will be float. Now it should compile and run, no issues. Just see here, please. Let me update this code. I'm making it as a float, and this one also I'm making it as a float, and save it. And then I have to compile and run. Let me check it's working or not. Once again, yes. Compiled. Just see here, compilation is working fine. Now I'm going to run. Running also fine. So it's working fine, right? So you have to remember that by default, decimal value like 2.0, 3.0, 4.0 counted as a double value. Okay, it's not an so I have to make it as float, then only same container is coming inside same container, no error, right? So this is another scenario you may have to face when you are working with data types in Java. Fine. Okay. Next, we'll talk about the second case 3 part. Okay. So let's talk about that case 3 part. Okay. So let's take it. Case 3. Now for case 3 part, what I can say here is like take case 3 like I'm writing here short s equal to 20. Fine. Short s equal to 20. Okay. And you can use short s1 equal to 30. So this is a short type data type. Fine. Now what I'm going to do, I'm going to do the addition between both of them and take any arithmetic operation. I'm using any arithmetic operation, it is applicable. Okay, so s plus s1. So I'm doing the addition between both the sort, right? And I'm taking inside another sort data type, short s2, fine, equal to. So that's it. So I'm doing some arithmetic operation between two short type data type. Right? So, and then I have to print, right? So let's print it. System dot out dot println, and what I'm going to print the value of s2. So what it will print, will work or not, right? So we'll see, and we'll execute and check whether it is working or not. Control C copy and open your file. Come to the third scenario, right? Now here, save it. Now here you have short s 20, short s1 equal to 30, short s2 equal to s plus s1, and it's going to print the value s2, right? Fine. So let me check it's working or not. Third scenario, fine. Okay. So let's compile the class. Now see here once again. See once again there is some problem, right? So what we find here is that incompatible types, possible loss conversion. So the problem is that the same thing when you're adding to short, type data type, okay, when you're going to add this to short type data type, right? What will happen after arithmetic operation between these two short, it will become int. You have to remember that. That is, you have to remember this one. As per API specification, it will become int after arithmetic operation. So if it is an int, now this is a sort, this is sort, and this is an int, right? So what is the size of int? Just check from here. Size of int is 4 byte, short is 2 byte, right? So this is 4 byte and this is 2 byte. What happened? Big container is coming inside a small container. That is the problem. So the point is arithmetic operation between two short type data type always return int. You have to remember this. Arithmetic operation between two short type data type will always return int. That's why this is returning an int. Int is 4 byte, short is 2 byte, big container is coming inside a small container. That is the problem. So what we have to do? We have to do typecasting. Here we have to typecast with short. The typecast with short, that int converted to short, right? So this is now it will work. Int converted to short. Now it will work. Now it should work, and this is called explicit casting. Explicit casting. Fine. Okay. So this one, just check it will work now. If we execute here, I have to typecast with short. and this operations between both of them, and then save as to save it. And if you compile and run, just check. So it is working fine, and you can see, right? So arithmetic operation between these two short become an int. We have typecasted with short. Now it is working fine, right? So this is the thing, we should remember these scenarios. Let's talk about the another one case 4. Case 4 about data types. Take it case 4. Take int. Okay. Int a equal to 10. Take int a equal to 10. Then I'm writing int b equal to 20. Fine. And what I'm going to do, I'm doing some arithmetic operation between a plus b. So a plus b, and the arithmetic operation between a plus b is like, right? And I'm taking it inside long L. So you can write long L equal to like this. Fine. So I'm adding a plus b and it came inside long. Fine. Okay. Then what I'm going to do, I'm going to print system dot out dot println, right? And here I'm going to print the value of L. That's it. Now if you see the scenario, here I'm going to do the arithmetic operation between two int, and it is coming inside a long. So arithmetic operation between two int is always an int. And what is the size of int? 4 byte. Fine. Now now long. What is the size of long? Long size is 8 byte. So the thing is, just see here, 4 byte is coming inside 8 byte. 4 byte is coming inside 8 byte. So small container is coming inside big container. Right? Small container is coming inside big container. So when it is, so there is no problem, right, from the size point of view, and container implicitly convert into an long. Container implicitly convert int to a long. So that's why we define it as implicit casting. Implicit casting. Okay. So this is another one scenario, and it will compile and run without any error, right? But we have to remember that this is how it is. Fine. Okay. Okay. Fine. Okay. So these are the 4 scenario you'll find. I've just mentioned some major 4 scenario.